Instead, I'm just going to be concentrating on the essential characteristics that can be declared as part of the CE marking, and also what is meant with the different characteristics of a structural steel product CE mark, and what kind of proof you are going to require to declare one of the characteristics. And then at the end, I'm just going to go over the FBC systems scope, that what you must develop and for which you must get the certification from the notified body. But this next issue that we're going to turn into, the essential characteristics that can be declared, is one of the probably one of the most interesting, and also at the same time one of the most difficult things to actually really understand in a CE marking project for our structural steel products. And this essential characteristics is one of the things that we have noticed is probably the least well understood part of the CE marking project. So I would just recommend that you take your time to actually understand what I'm trying to say here and what I'm trying to teach you. And with every other product, I would just go over the essential characteristics and tell you that you want to declare this and do it like this, and then declare that and don't declare that. But with these structural steel products, it's unfortunately not so easy. And the declaration of these essential characteristics, and especially to having the required proof behind the CE marking, is probably the hardest part about the CE marking projects. So instead of just going and diving directly into what kind of characteristics you have and how you must define them and how you can determine them, I'm just going to first introduce you or present you an example of a CE mark that has all the characteristics determined, and then we are going to translate that CE marking into plain English, that what is basically said with the CE mark. So here we have an example of a CE mark that could be affixed to a structural steel product. And here you actually can also see all the possible essential characteristics that can be determined for a structural steel product that we manufacture. And you can see there's actually 11 characteristics plus the small bit here about the manufacturing. So we have 11 essential characteristics that are all defined in the Appendix CA, and also information about the manufacturing of the structural product. So this is kind of like the odd child also here, the information about the manufacturing. But instead of just going over what tolerances on dimensions and shape and EN 1092 mean, let's just go over this whole CE mark and see what it actually says in English. And we're not going to go over this whole CE marking in order from top to bottom, but instead we're just going to go over it in a way that makes sense in terms of manufacturing. So we first go over those things that you would declare first or determine first, and at the last we are going to see those things that you would determine last in a manufacturing process. The first thing you would declare or could declare are these 4 characteristics that are related to the structural design. And by declaring all of these or some of these, you would be basically saying that we have designed this structure according to the Eurocode EN 19931 to meet the specified requirements for load-bearing capacity, deformation at serviceability limit state, fatigue strength, and resistance to fire. And you can see the calculations and results as an attachment to this CE mark. So here we are just declaring that this structural steel product has been designed according to the Eurocodes, and if the customer or whoever receives the product is interested, they can see the calculations, and they are sent as an attachment to the CE marking. But here basically the manufacturer is declaring that this product has been designed according to Eurocodes. there is more to this than just saying that it's been designed to the Eurocode. It's also saying that the design was done by competent designer, but that's probably a little bit too detailed at this point, so we're just going to be saying that the structure was designed according to the Eurocodes. Then what we are saying is that before starting the manufacturing process, we had a component specification. So the manufacturing was done according to a component specification, in this case CS123. The component specification is just a fancy word for engineering picture, so you don't get confused by this word, but I just want to introduce this component specification here because it's really widely used in the CE marking circles, and so you better get used to the word component specification. So before we started to manufacture this product, we had a component specification that had all relevant information that was required for the manufacture of this structural steel product. And this information included at least materials to be used, so what kind of mechanical fastenings we must use and what kind of structural steel we must use and so on. It also included dimensions and shape, so it had like this side must be 1 meter, height must be 5 meters and so on. And usually we also recommend that there is the tolerances defined here. So the height must be 5 meters plus minus 2 millimeters or whatever. But the component specification had the dimensions and shape defined. It also defined the corrosion protection system that must be followed. It also defined the execution class that must be followed. I'm not going to go too deeply into the issue of what execution class is, but it basically means the level of quality control or the level of detail that must be followed in the manufacturing. And while manufacturing this product according to the component specification, we followed the requirements of EN 1092. This EN 1092 is the standard that deals with the actual manufacturing of structural steel products, and it specifies how to perform the whole manufacturing process in terms of how to do holing or how to do mechanical fastening or how to do welding and how to measure the tolerances and so on in the execution class 2. So to reiterate, before we started to manufacture, we had a component specification that had all information that we required to manufacture the product, and we manufactured the product according to the requirements of EN 1092 in the given execution class. Then, this product was manufactured from structural steel S3550J0 that has a fracture toughness of 27 joules at minus 20 degrees centigrade. Well, actually, J0 means at 0 degrees centigrade and not minus 20 degrees centigrade. So we are declaring in the CE mark the product that we use to manufacture our structural steel product. Then, as specified in the component specification, we painted this product according to the standard EN 129445, and this has led to a reaction to fire class A1. So we had in the component specification there was it specified what we had to do in terms of corrosion protection. So we did that. Here we have basically said that we didn't really do any pre-treatment, and then we just painted it. And the paint we used to coat this structural steel product gives us a reaction to fire class A1. So it doesn't participate in the fire. But basically we are just declaring what the corrosion protection is and what the reaction to fire is. And at last, we are just saying that we also made sure that the finished product's dimensions and shape meet the requirements given in the EN 1092 with respect to the component specification we used. So again, the component specification to use and our tolerances meet the requirements given in the 1092. And if we want to just simplify quite a lot, and if we forget these requirements or these characteristics that are related to structural design, what we are basically saying with the CE marking is that we had a component specification before we started the manufacturing process, and it had all the information that was required for the manufacturing. And then we manufactured the product according to this EN component specification and the requirements of EN 1092, and this finished product is one-to-one with the component specification. So we had at the beginning we had a component specification, and now we have a finished product. And these two are 1-to-1. And that's basically the CE marking. We just say this is the CE marking part. And the thing I would like to just say here in the beginning, before we're going too much into detail of what are the essential characteristics and so on, I just want to say here in the beginning that CE marking is basically impossible without a component specification. So if until today, or if up until now, you have been manufacturing steel products without a picture, without an engineering picture, that's not possible anymore. Because in the essence, the CE marking is nothing more but a declaration that the finished product and the component specification are one-to-one. And this, if we forget the structural design or we don't perform any structural design. But let that be a little bit of intro into the whole essential characteristic thing, or essential characteristic part of the structural steel components. And now let's dive into more into detail of what kind of characteristics can be declared and how to declare them, and what is required if you want to declare one of the characteristics. And for this I have divided all the characteristics into 3 groups. And like before in the first lecture, I said that all these characteristics are defined in the Appendix C2, the same is here. And I have divided the characteristics into 3 groups based on where the proof comes from. And in the first group we have the characteristics that are based on the actual manufacturing. And these include tolerances on dimensions and shape, weldability, fracture toughness, durability, and reaction to fire. And if you remember from the previous slide, these also heavily rely on the component specification. So it is impossible to declare any of these characteristics without a component specification. Then we have those characteristics that are based on structural design, and these are load-bearing capacity, deformation at serviceability limit state, fatigue strength, and resistance to fire. And these are such characteristics that we are actually not going to talk too much in this training video, and we're going to go over them later, but these don't really affect the whole manufacturing process that much, as these only relate to the structural design, not the actual manufacturing that the CE marking is concerned of. And then we have the last group. We didn't even go over this group in the example because the release of cadmium and radioactivity are always declared as no performance determined, or NPD. So you can just basically forget these 2 essential characteristics, as they will always be NPD. But if we now take a closer look at these characteristics that are based on manufacturing, and I already mentioned you that these characteristics heavily rely on component specification, so before you can declare them. I already mentioned it quite quickly that this first essential characteristics that is related to the manufacturing called tolerances on dimensions and shape means that if you are going to declare it, means that you have properly checked that the product's dimensions and shape meet the essential tolerances requirement with respect to the component specification. So again, we have the component specification here. And the value or the class or however you want to call it that can be given to this essential characteristic is EN1092, meaning that the tolerances or essential tolerances meet the requirements of this specific standard and specifically Appendix D. So if you are ever going to declare the tolerances on dimensions and shape, you're basically saying that this product meets the requirements of EN1092 Appendix D. Then the next essential characteristics that you can define is weldability, and in addition to fracture toughness. So these two basically go together for most parts. Here you basically are just declaring what was the structural steel that you used to manufacture the structural steel product. Of course you can use also stainless steel and then you wouldn't have fracture toughness, but in most cases if you use black steel, you're just going to declare that what kind of structural steel was used to manufacture the finished product. And here you are basically saying, before you can declare it, that you have properly inspected and verified that the structural steel used to manufacture the finished product meets your or your customer's requirement that were specified in the component specification. And this properly inspected and verified means that before you started to use this S355J2 in the manufacturing, you verified and inspected that this steel was actually what it claimed to be. And I'm not going to go too deeply into how you can verify and inspect it properly, but here I'm just going to say you that you have done it and you're just claiming that you have done it. But in addition of properly inspecting and verifying that it meets the requirements given in the component specification, you're also tacitly saying that the manufacturing was done without destroying the structural steel's properties. So the product, the structural steel that we used to manufacture this product was 27 joules at minus 20 degrees centigrade. And even after manufacturing, even after we have done holing, we have done sawing, we have done welding, we have done corrosion protection, even after all these manufacturing steps, the fracture toughness of the structural steel is still 27 joules at minus 20 degrees centigrade. And this relates to the standard that you perform the manufacturing according to the standard EN 1092. So that in the manufacturing you follow these instructions given in the 1092. Characteristics that can be declared in the structural steel product is durability, and this basically means just what was done in terms of corrosion protection. Again, you just verify that this corrosion protection was done according to the component specification, also in terms of the standard EN 1092. So you did it properly, so the paint coating is going to be sufficient in terms of corrosion protection and it's not just going to fall off. But here you just declare that the component specification mandated you to do something and you did it. And as for the reaction to fire, you are just declaring what is the reaction to fire class of the structural product. This is always A1 if you haven't coated the structural steel product. And it's also always A1 if you have coated the structural steel product with a coating that has organic content of less than 1%. And in other cases you have to just ask from the coating manufacturer of what the reaction to fire class is. But this is usually just automatic A1. So in terms of these essential characteristics that are related to the manufacturing. We are declaring some characteristics that are actually based on physically testing the finished product, and this is the tolerances on dimension and shape. But for the rest of these, you cannot really check the finished product to determine what the weldability is, or what the fracture toughness is, or what the durability is, if you don't actually control the manufacturing process. So you cannot just say that, okay, we did actually use S355J2 to manufacture the product, but this is not sufficient proof for the CE marking, because you are still able to destroy the product during the manufacturing. So it actually doesn't have the characteristics of S355J2, especially in terms of fracture toughness. So it is basically impractical to prove that after the production that the characteristics have remained unchanged. So there must be another way to prove what the characteristics are with relationship to the manufacturing. So before you state that the weldability is at S355J2 or the fracture toughness is 27 joules at minus 20 degrees centigrade, you better have proof of it, besides just having checked the inspection or having done the inspection of incoming materials. You also must be able to prove in one way or another that welds are not a weak point. So if you are using, for example, S355 and you make a butt weld, you must be some way be able to prove that this weld right here doesn't affect the whole load-bearing capacity of this whole structure. And the only way you can do it is basically to have written procedure that allow you and the notified body to verify the characteristics indirectly. So basically you must have a written procedure for the manufacturing in terms of welding and cutting and holing and so on, that prove that you don't destroy the characteristics of the constituent products. And this is basically the problem with the structural steel products CE marking, that normally you only need to document the testing that you do to the product to determine the essential characteristics. And this is basically done once before you CE mark the product. And then you only set up the factory production control and documented it based on the instructions given in the standard harmonized standards Annex CA. But because this cannot be readily verified from the finished product, what you must do is to document also the manufacturing process, so you can prove it to the notified party and also prove it to other interested parties that you can actually manufacture the product without destroying the constituent product's mechanical characteristics. So what we are going to end up with is that you're going to have the FBC system that is used to control basically the overall activities of your company. And in most cases this would suffice. But here you're also going to have a manufacturing control system that is based on the EN 1092's requirements. So you are going to have to develop written procedures on how to do welding, on how to do mechanical fastening, on how to do holing, on how to do thermal cutting and so on, to prove it to the notified body that you don't destroy the characteristics. So you can actually declare characteristics called welding or weldability or fracture toughness and so on. And this is the problem with the structural steel products, because the documentation requirements are much bigger than in most products, because you have to include the actual manufacturing in the FBC.